Hello guys, welcome back to my YouTube channel. In this video, I am going to discuss a coding question which is asked recently in TCS NQT. Let's see it. So this is the problem statement of our today's coding question. The problem statement says that a football coach is selecting players for a tournament. The coach has a list of players with their fitness scores. The coach wants to select a team such that sum of fitness score is maximized from any contiguous group of players in the lineup, that is sub-array. Helps the coach find the maximum possible from any contiguous sub-array. The constraint given to us is n is should be greater than 1 and less than 10 to power 5. That is input format given to us like in first line we have to take an integer n, and in second line we have to take the n space separated integers, like we have to take an array of size n as the input, and we have to display output as a maximum subarray sum. So let's see how to solve it. So this is the sample input output of our problem statement. Here input is 9 and we take 9 element as a input, and output is 6 because the maximum subarray is 4 minus 1 2 and 1, which sum is 6. In example 2, the input is 5 and all are the positive elements. So entire array is the maximum subarray. In example 3, input we take 5 and we take all the 5 element as a negative element. So output becomes the maximum of them. The maximum element itself is the answer. Now let's see the first brute force approach. First idea is brute force. That is, we check all the possible subarrays and calculate their sums. For example, this is a array and we need to find the maximum subarray sum for this array. So all the possible subarrays are 1, minus 1, 2. These are all the possible subarrays. The sum of there is here, sum is 1. Here the sum is become minus 1. Here the sum is 2. The sum here sum is minus 2. Here 1. And, and last here is 3. So the maximum subarray sum is 3. So this become our answer. But in brute force approach, the time complexity becomes n square, and which we do not want because which is too slow for the n equal to 10 to power 5. This is the implementation of brute force code, which takes one array and maximum sum as a integer dot min value, which means it assign maximum as a minus infinity, and we traverse the array, and here we declare current sum as a 0, and it travels. This loop is for finding subarrays for 1, for first initially 1, then minus 2, 6 and minus 1 and 3, etc. And it finds all the possible subarray sum and it compares current sum is greater than maximum. If this condition is true, the maximum will be updated. By this way, we can get our answer, but this is not an ideal solution because time complexity it becomes order of n square, which is the worst time complexity. So to improve time complexity, we need a one ideal solution, and let's come for it. We solve maximum subarray sum in order of n time complexity using Kadane's algorithm. Instead of calculating all subarrays, Kadane's algorithm decides at every element should we start a new subarray or extend the previous one. If the previous subarray it becomes minor negative, so it will start with new subarray. Here is the formula for Kadane's algorithm. Current sum equal to maximum of array of I, comma, which we update current sum plus array of I. Whichever is greater is assigned to current sum. And in max sum, we compare both max sum and current sum. and we take the maximum 1. Now let's see the dry run. Let's dry run this example step by step for Kadane's algorithm. Initially, for index value 0, current sum is we declare as a array of 1, that is array of 0, that is minus, here is minus 2, and maximum sum also is minus 2. ARR of 0. Here, remain. So maximum sum is minus 2. For index value equal to 1, the value is 1 and 1 is greater than minus 2. So current sum is updated and maximum sum is also get going to be updated. For index value equal to 2, the value is minus 3 and so current sum is 1 plus minus 3 minus 2, and the maximum sum is 1 which is greater than minus 2, so maximum sum with which is not going to be updated. For index equal to 3, the value is 4 and here 4 is positive number, so we start here new subarray. So current sum is become 4 and maximum sum is also updated as a 4, and for index equal to 4, value is minus 1 and current sum is 4 minus 1 equal to 3, but maximum sum will not going to be updated because it is greater than 3. So for index equal to 4, for index equal to 5, the value is 2 and 3 plus 2 is 5. So current sum is become 5 and 5 is greater than 4. So maximum sum is also going to be updated. And for index equal to 6, value is 1 and 5 plus 1 is 6. And maximum sum is also going to be updated as a 6. So here we get our answer as a 6. Now let's see the code implementation of Kadane's algorithm. This is the code implementation of Kadane's algorithm. Here we take this array and current sum is AR of 0, that is minus 2, and maximum sum is also minus 2. And we take one for loop to traverse the array, and we use our Kadane's algorithm formula, that is current sum equal to mat.max, which is given as maximum value from both of these, and we take array of I and current sum plus array of I, which compares previous elements, and in max sum we take maximum of maximum and current sum. By this simple way we can get the answer as a maximum subarray sum. This is the Kadane's algorithm, and for this Kadane's algorithm the time complexity becomes order of n, which is the good time complexity. Good time complexity. So this is the best solution for our problem statement. The students who do not use Java, here the reference solution in Python and C++ I attach in the PDF. Thank you for watching this video. Please like, share and subscribe.